we realized that we were going to start solving equations where the variable was an exponent. And the way we solved them yesterday was to make the bases the same. So the bases would be 2 and 4. We need to somehow make those the same. We could rewrite 4 as 2 to the power of 2. And then it would still be to the power of x plus 2. Right, so we were changing everything so that it had the same base. Now we have a base of 2 and a base of 2. We used our exponent laws to multiply those two together. So 2x equals 2 2x plus 2. So we've made a common base. We made it so the exponents were set up nicely, like we expanded if we had to, which we did. And then we realized that we could just focus on the exponents. And if we could make the exponents equal each other, because the bases already were the same, then they would obviously be the same thing. So we would just focus on the exponents, solve that, and you would end up getting negative 2 equals x. No matter how you solved it, that's what you would have concluded. Yeah, I would have subtracted x from both sides. Minus x, and then minus 2 from both sides. These x's cancel. 2x minus 1x would have been left. And then minus 2 would have been left on the left side by itself. So that's what we learned yesterday. These ideas of common bases, like bases, same bases, similar bases, all the same thing, just different terminology saying that the base is the same thing. Solve the exponent afterwards. So we can do 2 more of these, just for review's sake. So we looked at this one. We have 6 and 36 as our bases. We want to see if we can't rewrite one of them. We can definitely rewrite 36 to be 6 to the power 2. And then it'd be x minus 1 still. We used our exponent laws to multiply our exponents together. So I would have 6 to the power of x minus 4 equals 6 to the power of 2x minus 2. And again, you have 2 exponents, and you have the same base. You just have to focus on that part of the question once you break it down that far. Again, we solve this thing, we move our x's over to one side, our constants together, we get negative 2 equals x. Coincidence, it's the same thing. I would have subtracted an x from both sides, subtract x, and I would have added 2 to both sides.
Do you have to divide it?
I wouldn't have had to because 2x minus x would have been 1x.
Oh.
Is you subtract 1 from that, the 1 just disappears?
What do you mean 1?
If you subtract 1 of the x's?
Yeah, because I would have 2x minus 1x. Which would be 1x.
Yeah, so that's multiplied, so that's how many x's. Like, okay, so the
I had 2x.
X to the x's is the amount of x's you have?
Yes. It is multiplied, you're right. Yeah. No, you're right.
For some reason, I think that's
Yes. Alright, the next one. A little bit trickier. And the reason it's a little bit trickier is going to a like base of 7 isn't as easy as this looks. So, most people would look at this and realize 7 and 49, those can both be like bases of 7. They would change that 49 to be 7 squared to the power of x minus 2. They'd multiply the 2 in. They'd have 1 over 7 equals 7 to the power of 2x minus 4. The reason this doesn't work is that your bases are not the same right now. They're both 7, but this is a 1 over 7. So that's not good enough. It needs to be just 7. So what we need to do is get it out of that fraction. To get it out of that fraction, we change it to become 7 to the power of negative 1. So to get something from the bottom of a fraction to a top of a fraction, you give it a negative exponent. If this had been 7 squared, I would change it to 7 is negative squared. If it had been 7 to the power of 2x, it would have been 7 to the power of negative 2x to move it up to the top. And then at that point, we can focus in on just the exponents. But not until the bases are the exact same. They got to look the exact same. So negative 1 equals 2x minus 4. I'm going to add 4 to both sides. 3 equals 2x. I'm going to divide both sides by 2.
Do you always want it to equal like the second number after equal signs equals?
What do you mean, sorry?
Like, we like in our question, we change the number after the equal sign.
Oh, it doesn't matter which way you go.
Oh, it doesn't.
No. So if I went the other way, if I had moved my x over here, if I went over there, it would have worked out the same. Yeah. It doesn't matter which way you solve it, as long as you're getting x by itself. Yeah. I always, at the grade 10 level, I always solve it one direction to make it easy for them. That's my favorite band. And at this level, I just solve it to. That's so good. At this level, it doesn't matter to me. I can go both ways because it's 2017. So I just solve whichever way I think will be easy. And you know what? It varies between people. Like some people might be like, I don't like it over here. I need it to say x equals, and that's okay. Like to me, I leave it over here because it's positive. Just the way it is, because I'm a positive guy. All right. This idea of same bases and solving things that can be like bases is going to quickly vanish from your mind because we're about to learn something more complex. And I don't want it to vanish from your mind because it's the easiest way to solve a problem. It's not that challenging. It takes some practice to get good at, but once you're good at it, it's easy. Okay, so sometimes you're going to get a question, and that's the easy way to solve it. It's like factoring. You know, everybody always wants to jump straight into diamond method or difference of squares or something because you know all these good strategies and you forget a simple GCF at the start of it. Same idea. If you can do a like base, do a like base. Yeah.
Will we ever get questions that's like 2x to the power of x plus 1?
It's possible, yeah. And if you had the same base of 2x and 2x, that's okay. Yeah.
So say we do the complex way.
Yeah.
So like.
You should still get it right. It's just going to be more complex. And sometimes it won't be doable. It might be too hard if you try to do it the hard way. So, sometimes you can't do like bases. For instance, look at this thing. You have 2 to the power of x equals 5. I can't change either of those to be like base. I'm not going to change 2 to become a 5. I'm not going to change 5 to become 2. There's no way to rewrite those to be the same base. And I'm going to have a really hard time estimating what x actually equals. I could probably do it. I could probably guesstimate a little bit. Because if it was 2 squared, what would that equal? It'd be 4. If it was 2 to the power of 3, what would that equal? 8. So my answer is probably going to be a little bit more than 2, right? Like x probably equals, I'm going to put a question mark above it, it equals like 2.3. I don't know. But it's somewhere in that range. I can only estimate, and that's all you've ever been able to do up until this point. We're going to learn a way to solve what that exact number is. To do that, it's called a logarithm. Okay, this is why logarithms exist. And one of the things I first ask people all the time when they do, especially Math 30-1, because they do a lot of log problems, is they'll be like, I don't know how to solve this. And I'll say to them, why do logs exist? Like, what's the purpose of it? The purpose of a log is to solve for an exponent that you don't know. Okay, that's the purpose of a log. And that's going to be important to understand like what's actually happening when you start doing questions. So this equation right here can transform to become that equation right there. So there's pieces to a log. The pieces to the log is the value that it's actually equal to. So the x, I'd call that the value. The number 2, I would call that the base. And number 5, I would call that the argument. It's written down below, so you don't need to worry about writing it out because I didn't write it out. It is all below. So the little tiny number, it's called a subscript, that's your base. The bigger number is called your argument, and the number that's now by itself is called your value. This thing right here can actually be calculated. It's a value in your calculator. So if you pull out your calculators, you don't have one, look at your neighbor. Depending on your calculator, depends how these things can be solved. So you should find your log button over here by the number 7. If I hit my log button, what comes up is a bracket. So it goes log bracket. If you have one of those newer calculators, do you mind if I look and see what happens? Same thing. Oh, good. I thought I gave you a chance to break the subscript. It doesn't give you an opportunity to write that number right there, does it? No. So what you need to put into your calculator is log 5 divided by log 2. And that's how you're going to write these things into your calculator. It's called a change of base, is the actual term for it. But you can always do this. So you would go log 5, close the bracket, divided by log 2, close the bracket, hit enter, and it'll tell you the exact value that x equals. It's 2.32, and I'll say 3. So just keep going. And it goes through. Okay.
In some of the calculators, you can type it in.
I thought you could.
Like, are you going to use calculator or something?
So the way that we would write this is you're log 5 divided by log 2. When you see log written like this, and we will discuss it in the future, there's an invisible base here. If they write log and there's no base, it's base 10. Okay, so that's what your calculator is automatically calculating in. It's automatically going to base 10. So what we did is something called a change of base. We changed it to both of them are base 10, and we can rewrite it as log 5 divided by log 2. Yeah?
How do we know to put log 5 first?
The argument always goes on the top. Smaller number always goes on the bottom. That's a good point. So when you're trying to put this in your calculator to calculate what the value is, the base is the bottom, B and B. The argument's the top. Yeah. All right. The next thing when I talk about logs is like a log to me, you can read it out. So the way that it reads is 2 to the power of x equals 5. So I could rewrite this thing in exponential form by understanding what a log means. The base to the power of the value equals, that's how you could rewrite that thing. These things are the same. They're just changing the form of the question. A lot like how we would do something like this, x squared equals 4. We could convert that to be x equals the square root of 4, right? And we could convert those things. This is us converting exponential form to log form. And we're doing that so that we can solve for the exponent. Yeah.
If 5 were to have 6,
Then it could go with it. So if this had been a 5 squared, then the 5 squared could come in there. But if it was 5 to the power of x or something like that, you couldn't even solve that question. So don't worry about that. Logs convert exponents so that you can actually solve them. That's the big thing here. That's why logs exist. It's what they're for. We're going to try converting a few of these. And then we're going to convert and solve them just for fun. So if I want to convert this thing and solve for what x is, the first thing I'm going to try is a like base. I can never like base that thing. So I know I have to rewrite this in log form. So I'm going to go log 5 of 2 equals x. So I'm rewriting that thing. The base becomes the little number, the value becomes your argument, and the old exponent is now by itself on the other side of the equal sign. To try calculating the calculator, you go log 2 divided by log 5. Make sure you close your brackets. So log 2, I didn't close my brackets, divided by log 5, 0.43 equals x. It'll tell you what you need to round to on an actual question. Alright, let's try another one. This one, a little bit tricky. So, we need to figure out what x equals. X is an exponent. The only way I can figure out what exponents are is by doing like base or log form. Can't like base that. But I could log it. So I'm going to change this to some log 6 of 9 equals 2x. I don't want to know what 2x is. I want to know what x is. So how can I get x by itself? Here.
Divide by 2.
Divide both sides by 2.
Could you figure out the log?
100%. So I would calculate this thing first in my calculator, and then divide by 2 to figure out the actual answer. Because putting all that in your calculator gets a little like mumbly-jumbly, right? So I would go log 9 divided by log 6, hit enter. So I have 1.22629, and then I would divide that by 2. To figure out that my answer is 0.613 equals x. All right. We'll try another one. So, I have to solve this equation for x. X is in the exponent. The only way I can solve for an exponent is if I have like base or if I log it. I can't like base 3 and 2. So I need to change it into logarithmic form. So I'll go log 3 of 2 equals 3x plus 2. Once it's converted into log form, your x is no longer an exponent. So now you can actually solve that. I'm going to calculate log 2 of 3 just to see what happens. So if I go log 2 divided by log 3, I get 0.631 equals 3x plus 2. I put it in my calculator to get that decimal, in case you're wondering. It's a crazy decimal. Now I just need to get x by itself. So I need to subtract 2 from both sides. So I have negative 2.631 equals 3x. I put that in my calculator that is not negative 2.361.
Negative
1 point, yeah. 1.3, what is it?
3, what? 3,
6, 9.
yes.
Yeah, I'll do 3 decimal places. And then my last step would be to divide by 3. So you're taking exponents, you're changing them, minus 2 divided by 3, changing them into equations you could actually solve, and then you actually solve them. Alright, there's 3 more there. I want you to try converting them into log form, and I want you to try calculating to see if you can actually get the answer for it. I'll put my answer on the board, but I'll also come around and check you out and see if you have any problems. What you got? First one is a basic one. You need to solve for the exponent. To solve for the exponent, we change into log form. Something that we were talking about over here that I want to be made clear is like the terminology can sometimes help you figure things out. Like in this question, 1.5 is the base, right? I would have said 1.5 to the power of x. In the log question, the term base is used again for that little number. And notice that the base and the base is always the same number. That's why they use the same wording, right? And it's not a coincidence. So that can sometimes help you out, especially on later questions that get a little more complex and they get a little bit crazier. So that terminology is used purposely. The old solution over here becomes right in there, becomes your, I think the terminology is argument. Yeah. And then the value is the exponent. So x is going on the other side. That I put in my calculator, so I went log 3 bracket divided by log 1.5 bracket. Enter 2.71. It goes on forever. Right? You can test this. Put 2.71 in your calculator. 1.5 to the power of 2.71 should equal really close to 3. If you did it right. I mean, we rounded, so it might be just slightly off, but it should be almost spot on. So when I did it, and I went 1.5 to the power of 2.71, I hit enter, my answer is 3.00059. The only reason it's not 3 exactly is because I rounded. So you can test to see if your answer is right. This guy over here, I did the same thing. The base became the base. This became my argument. And then 2x is now on the other side, and it's no longer an exponent, so I can actually solve for the value of x.
Yeah, you solved it. What were you using?
Did you change the base? Yeah, you changed the base to? Yeah. So that's good, because you can actually change a base that way. So that's why your number came out as a nice number of 1.5. If you actually tried to, like, all these answers, you notice we've been getting crazy decimals? For the first time ever, we actually got 1.5, which is a whole number, or a well-off rounded number. It's not an irrational number. It's the terminology I'm looking for. That's a sign that I couldn't change the base that thing. So 4 times 4 is 16, times 4 is 64. So I could have changed that to 4 to the power of 3 to the power of 2x. Or sorry, 4 to the power of 2x equals 4 to the power of 3. And then I could have solved it. So you could have changed the base that thing, or you could have logged it. Either way, you would have been good. Yep. The last one, definitely the hardest one. The reason it's hard is it's in a different order than we're used to. So you need to be comfortable with saying, all right, I understand this is the base, so it's got to be the base of my log. This was the old value, it's now my argument. And the exponent comes down to the other side of the equation.
How would you put this in your calculator here?
Okay, that's a good question. So once I isolate it, you see I subtracted 1, because I have to do that first part, and I divide it by 2. Now what I'm going to do is I'm going to do this thing in order of the same way I just did it. So in my calculator, I would go log 3 bracket divided by log 5 bracket. And I'd hit enter. And that's giving me a value for this thing right here. So this guy equals 0.6826. Then I would subtract 1, minus 1, and then I would divide by 2. To get negative 0.5. So I would subtract 1 from that number I got.
So you get the log 5 divided by 2.
That is log 3 divided by log 5. Right? The 5 is the base. Yep.
The problem I had with this where I got confused. Why did you subtract?
I was sitting here thinking to myself the same question. So I was like, bed mass, which is what I'm assuming you're saying. Like, bed mass says I should have done it this way. Right? Like, I should have gone this. Okay, when I divided by 2, I divided this whole thing by 2. And what we don't do is we don't put it in brackets, but we should. Because when you're dividing an entire thing, you're saying that's a package, so that needed brackets. So BedMass would have said, do inside the brackets first, then divide by 2.
Well, your calculator does it for you too. You just do the log, or the log.
Yeah.
And don't even press anything after it. Like it gives you the answer, the decimal, and then you just press divide by 2, and it gives you.
Like you go log 3 divided by log 5 minus 1?
Well, no, okay, so I put the log in, like log 3 divided by log 5.
Yep.
And then I took away the 1 from that, and then I just divided by 2. I didn't even
That works.
rewrite.
Your calculators will just do everything in order. So, like, your calculator would have done the division first, so that calculates the log, and then it would have done -1. So it just goes in order. It doesn't think. Right? It doesn't have a program in it for randomize. Yeah.
There's no rush.
All right. That's how we solve for exponents we don't know. You're going to have to go the other way around, too. So, now we're going to get given log questions where you don't know something inside of the log. So you could convert this thing back into exponent form to be able to figure out the value inside the x. So if you have a log and you're trying to solve for something that's in the log, you convert this thing back into exponential form. This would be 2 is the base, 3 was the old exponent, equals x. So that's converting it back the other way. That's how these things get hard, right? Because we're going to be going back and forth. So if you understand why logs existed to be able to help you solve exponents you didn't know. Well, now if you're trying to solve a log, you know you can turn it back into an exponent to make it work out. And then you can always double check to see if you're right. Like, try converting that back and see what would happen. Log 2 of x equals 3. Do some practice on these ones too. So, here's a question. We have to figure out what x equals. Yep.
Can we go back for a second?
Yep, for sure.
If you wanted to check if log 8 or log 2 of 8 actually equals 3, how would you do that?
So, we're saying x equals 8. That means log 2 of 8 should equal 3. So my calculator, I would go log 8 divided by log 2. And it does in fact equal 3. So it worked out. Alright, solving a log. To solve a log where you don't know a value, you turn it back into exponential form. So this thing's going to become 6 to the power of 2 equals x. The base becomes the same, but the argument is the value swaps spots. Right? So it's 6 to the power of 2 equals x. That means 36 equals 6. Try another one. Convert this thing back into form. So 1 to the power of 6 equals z. What's 1 to the power of 6 going to be? 1 equals z. Now, with that thing, we'll talk about that in a second. Let's solve the other one. This one, the x is now the base. So that changes a little bit. But I still don't know part of the log. So it's still going to be advantageous to switch that thing into exponential form. Yeah. Square root it. So x equals 2. Yeah. So either way, if you don't know the argument or you don't know the base of a thing, you can definitely change it into exponential form and solve it. Sometimes you're going to have to square root it or third root it or fourth root it to get it, and sometimes it's just going to be the answer right there. All right, like I said, and like we just talked about this here, you can check your answers on this thing, for sure. However, you should also be able to check to see if something makes sense or not. How could I do that? Like, check this one right here and see if that thing would actually make sense. So if you put that in your calculator and you went log 1, because z equals 1. So I'm saying log 1 of 1 equals 6. If I went log 1 divided by log 1, what do I get for an answer? You should get in there. Yeah. You in there? Awesome. Why do we get an error? Because 1 to the power of 6 equals z. Okay, z has to be 1. Put that back into your log and think about what this is saying, and it doesn't make sense. So the power of something that's going to give you 1 would have to be 0. That's the only exponent that works out. Like anything to the power of 0 equals 1. So that is like one of those odd situations where it might not actually work out. Your calculator, if you test it, will always tell you it's an error. You're never going to run into that again. If you do, for some reason, if you're practicing out of somebody else's practice booklet, or you're practicing with a textbook or something, you might end up in these situations. We're going to talk about that. Okay? So, like, this is a situation that comes up more in the future, I think in 2 days. We talk about the rule that makes that happen. But for now, because I know sometimes you guys are using other people's stuff, and you should. So like, if you're working in your key, or you're working in another textbook from another tutor, or whatever you're doing, that's good. Just understand that if you get an error or something, it might just because logically it's not making sense. Alright, your turn. So try those next 3 down there. See if you can convert them around. See if you can solve them. At the very least, see if you can convert these into exponents. So try your absolute best. Things. Log 7x equals 0.5. I'm going to rewrite that as an exponent because it's part of the log that I'm looking for. When it's part of the log I'm looking for, it's better to be in exponential form. And like, you're not going to get a question that says change this to exponential form. You're going to just have to know if I'm looking for something that's in my log statement, I need to change it. And same vice versa. If I'm looking for something that's my exponent, I need to change it in the log form. Knowing the purpose of what you're doing will make it easier to think about how to do questions. That's 10 to the power 0.5 equals x. Put that in your calculator to 2.65. This one, log 0.1 x equals -3. If you put that in your calculator, you get 0.1 to the power -3. You're going to get 1,000 equals x. And if you tried it out, so you can test your answers. So you go log 1,000 divided by log 0.1, and your answer is -3, and it works. Remember what this is saying. If you had some confusion over why it equals 1,000, 0.1 to the -3 means 1 divided by 0.1 to the power 3. Right? You could flip it, which means 1 divided by 0.1 times 0.1 times 0.1. And if you times it by a decimal, a decimal, a decimal that are on the bottom, they're making the number bigger and bigger and bigger, which is why it goes up to 1,000. This last one, it's the base that you're looking for. So you had to change it into exponential form. It was x to the power 4 equals 81. You had to 4th root both sides to get it. The answer was just 3. Again, you can test your answer to see if that's right. All right, that's the basics of logs. So tomorrow what we're going to do is we're going to do something called a natural log. We're going to do something called log laws. And then the day after that, we're going to do more log laws. So we're about to do a lot of log stuff. Then we're going to have a quiz when we come back from the weekend. Okay, so it'll be on everything we've done this week. Then we're going to graph logs. And things, the graphs of logs are kind of crazy. And then we're going to do log word problems. So
What next?
get very, very comfortable with the basic log stuff. Because if this part is mind-blowing to you right now, then the next stuff's going to get really crazy if you don't at least study it a little bit and work with it a little bit. Just get comfortable with what's happening.
Yeah, punches and things. Never learn anything.